In this course, we'll look at the subject of IPv4, covering the following points. First, we'll look at what an IPv4 address is actually used for, then how we can calculate it, and finally how we can identify its IP class. The IP address plays a decisive role in the user's connection, enabling him to access and communicate data to terminals. The IP request for information or communication is made via the LAN private network to access an internal resource, or via the public WAN network to access an external resource. Let's look at an example of network interaction. The user wishes to upload a file to a remote cloud storage space. Initially, when the file is sent, the user terminal prepares the data transmission by splitting the message into IP packets. This IP packet contains the file data and all the protocol information indicating the nature of the transmission. An IP header is added to this IP packet to route the transmission. The switch receives the IP packet from the user, checks the switching data, and relays the message to the recipient. Once the server has been contacted, it sends back an acknowledgement to confirm the transfer once the operation has been completed. Once we've understood this example, we can determine the IP address using an IP addressing calculation. First of all, the IP address is made up of 4 blocks of 1 byte. Each block of 1 byte contains 8 bits. These 8 bits are binary digits of 0 and 1. Each of these bits is a power of 2, from 0 to 7 bits. The sum of all the blocks forms a maximum byte of 255, and the maximum IP address we can obtain is 255.255.255.255. To simplify operations, there are combinations that facilitate calculation and reduce errors. The sum of the first 4 bits is 240. The sum of the last 4 bits gives 15. And finally, there are some combinations on the left-hand side of the block that are useful to know, such that the first 2 bits give 128 plus 64 is equal to 192, the second and third bits give 64 plus 32 is equal to 96, and finally the last 2 bits give 32 plus 16 is equal to 48. This binary IP address is taken from an IP frame, and the aim is to determine the decimal value of each block. First, we select all the bits that appear at 1, we sum up all the numbers corresponding to the retention. For the first block, we retain the first and second bits of the binary block that are set to 1, sum them and obtain 192. We keep 192 as the first byte of our IP address v4 of 4 bytes. Secondly, we retain all the bits that appear at 1, we sum the set of numbers corresponding to the retention. For the second block, we retain the third, fifth and sixth bits of the binary block that are set to 1, sum them all and you get 44. We keep 44 as the second byte of our 4-byte v4 IP address. For the third and fourth blocks, we also perform the same operations. This gives us 40 for the third block and 1 for the last block. We therefore obtain the following decimal IP address, 192.44.40.1. After illustrating an example of address calculation, let's look at IP address classes. An IP class refers to a classification of IP addresses used to organize and allocate addresses on a network. IP addresses are therefore divided into several classes to meet the needs of different types of network, whether small, medium or large. Classes A, B and C are the most widely used. Class A has a wide address range and is used for large multinational networks and large organizations. We have up to 16 million IP addresses available per network. Class B has a smaller address range and is used for medium-sized to large networks for universities and businesses. We have up to 65,536 addresses per network. Class C has a smaller address range and is used for small corporate networks, with up to 256 addresses per network. Classes D and E are not reserved for end-user terminals. Class D is used for multicast, enabling messages to be broadcast to a group of hosts on the network. This class is not used for network or host identification, as it is reserved for specific communications. And finally, Class E is not put into service, as it is reserved for experimentation or future use. The class-based approach proved inefficient as it limited the flexibility of IP address management. Today, CIDR is mainly used, a classless method that allows better use of address ranges thanks to variable VLSM subnet masks, which we'll see in another video. CIDR has alleviated the problem of IPv4 address exhaustion. To finish this video, a few tips to help you remember and identify IP classes. Note that at the beginning of each IP class, only the first byte changes, and that the end of the class reaches the maximum limit of the IP address. Each class is optimized so as not to waste any address, so there is a difference of 1 between the classes. To find them in a class, just look at the first byte in binary, and you can see that each class increments by 1 bit from the left. Thank you for taking this course. Don't hesitate to subscribe to access more educational content.